Okay, we're going to start chapter 02 or section 02. It's very similar like the first one, except instead of changing from the metric system to the metric system and from the English to the English, we're going to go between the two systems. Okay, we're going to go between the English system and the metric system and vice versa. All right, so let's start with a little chart here. Oops. There we go. There's the chart. And this chart right here shows you the conversions to go from the English to the metric. Here are the English units right here. So 1 inch is 2.54 centimeters. Now I have equals right here, but these are all approximately equal to. It's not exact, but it's very close to it, okay? I think the book just says 2.5. I've always taught it 2.54, so I'm just going to use this one. So 1 inch is about, this should be approximately, I just didn't have the key on my computer to make this an squiggly. It should be like little squiggly equal sign. But 1 inch is 2.54 centimeters. So 1 inch is bigger than a centimeter. It takes a little more than 2.5 centimeters just to make up 1 inch. All right, 1 yard is equal to 0.9 centimeters. That's wrong. I need to change that. I'm looking at that. There's no way that's right. There we go. That's better. So 1 yard is 0.9 meters. All right, that sure didn't look right. So it means a little less than a meter. 0.9 is a little less than 1 meter is a yard. Okay. If you look at it the other way, 1 meter is, or approximately, 1.1 yards. So it takes a little more than 1 yard to make 1 meter. And there's a little less of 1 meter that makes a yard. A mile is a little more than 1.5 kilometers. Remember, we measure distances our cars travel, okay, in kilometers. So 1 mile is 1.6 kilometers, which means a mile is bigger than a kilometer. It takes one of the, or it takes a little more than 1.5 kilometers just to make 1 mile. So 1 mile is bigger than a kilometer. All right, and you can see the rest. These are just inverses basically. Okay, if I took the inverse of this, it would be 0.4, the inverse of this would be 1.1, and the inverse of this would be 0.6. Just goes the other way. So metric to English system. All right, enough of that. Let's do an example. And here's the first example. Let's change colors to yellow. And let's see, 30 inches. So this is right in the book. Oops, that's crazy looking. Forgot to change something up here. All right, now it should work. So let's go 30 inches. Let's make that a little thicker so it shows up a little bit better. And equals how many centimeters? Equals, put a blank right there and a question mark. How many centimeters? Now this should be approximately equal. I'm not going to be real picky about that. I'll just put the equal sign down. So what do we do? What did we do in the last lesson? We took 30 inches, what we start with, and I always put it over 1, and I need to multiply it by a unit multiplier. Remember, these things are equal to each other. This is equal to this. This is equal to this. So I can use one of these, put one of them on top, put the other on the bottom, and they're equal to each other. And that way, it's a unit multiplier. It means I can multiply by 1, because anything over itself is a 1. So what am I trying to get rid of? I'm trying to get rid of inches. So where's inches going to go? It's going to go here on the bottom. Why do we put it on the bottom? Well, we put it there so we can cancel these inches out. What do I want to change it to? I want to change it to centimeters. Does any of these change from inches to centimeters? Actually, you could use one or the other. You could either use this one here or this one right there. All right, so really, you don't even have to memorize this one. You could just memorize one of these, of each of these 3 right here, and that'll work either way. So let's do this. 1 inch, 2.54 centimeters. So I'm going to put 1 inch right here, and then the top has to be centimeters, and that's going to be the 2.54. Just like that. All right, very close, very, very close to what we did yesterday. We're just changing from the English system to the metric system on this. So the inches cancel out. Look, I got 1s on the bottom, so I don't have to worry about dividing. All I have to do is multiply those 2 together. So let's just use our calculator to do that. So it's 30 times 2.54, 2.54, and I get about 76.2. Now, if you look in the book, it says 75. Why would it say 75 in the book and I got 76.2? Because I'm using 2.54 centimeters. I guess I really don't need to. I probably should stay consistent with the book, but I don't know. It's kind of like old habits. I've always used 2.54 when I do this. It's a little bit more accurate this way anyway. All right, so let's just write 76.2 centimeters. So you say, well, what about on test or quiz or something? Let's use my numbers. Okay, let's use 2.54 instead of the 2.5. I think that'll be better. And there you go. So 30 inches is 76.2 centimeters. Let's do another one. Scooch this down. Well, I'll tell you what. We'll slide it over. We can put it right here. This one is 5 kilometers. 5 kilometers equals how many miles? Okay, 5K. That's a common race people run all the time. They want to raise money for some kind of a organization or some kind of what would you call it? I can't even think of the word. But you're just trying to raise money for somebody, and they have these races all the time, fun runs and all this kind of thing. They call it a 5K. Well, it's 5 kilometers. Well, let's figure out how many miles 5K actually is. And I believe when the cross-country runners run, I believe they run a 5K. Well, let's do this. We always start by putting that over 1. And now we're going to change it from kilometers to miles. So let's look. I could either use this one right there because that has kilometers and miles, or I could use this one right here. That has kilometers and miles. Now, if I'm starting with the metric system, which is kilometers, what would I have to put down here on the bottom? I'm going to have to put kilometers down here on the bottom. Now, what would you rather have here on the bottom? Would you rather have a 1.6 or would you rather have a 1? Probably a 1. That makes things a little bit easier. So that might be a good way to use this column right here. But you could do it the other way around. You could put, let's see, 1.6 down on the bottom and a 1 on the top. But then you'd have to do some division. But since you're using a calculator, it really doesn't make that much of a difference. Let's just put the 1 on the bottom. So kilometers, I got 1 kilometer, and I want to change it to miles. So how many miles does 1 kilometer equal? It equals 0.6 miles. So I put a 0.6 right here. And now I just multiply those together. The kilometers cancel out. The bottom is just all 1, so I don't have to divide. This is just multiplication. 5 times 0.6. Well, look, we could probably do that in our head, couldn't we? 5 times 6 is 30, but then you move your decimal, and that would just be 3. So it's about 3 miles. Now remember, I said approximately. I think it's more like 3.1 miles or something like that. But when those cross-country runners run their race, they're running a 5K. That's approximately, it's not exactly, but it's approximately 3 miles. All right, I almost forgot. Before we get to the next section, I got one more example to do. Let's do this one. It's very close to what we just were doing. So they start off with 2,000 yards, and we want to change that to kilometers. Kilometers, and put a question mark right here. Tell you what, let's go back up and see, do we have yards and kilometers? Well, I got yards and meters, but I don't have yards and kilometers, do I? So look what I'm going to have to do. I'm going to have to go from yards to meters, and then, let's see, go from, let's see how I want to do this. Nope, we want to go to miles, so let's do it like this. I'm looking at how the book does it, but I think I might want to do it another way. I don't know, let's see how the book does it. Okay, I got a little confused myself because I was just looking at this chart. We're going to have to think back to yesterday's chart as well. So what I'm going to do is this. I'm going to go from yards to meters, which I can do right here. Okay, so I'm going to use this one right here to go from yards to meters. Now that I'm in meters, I got to go to kilometers, which is the same unit. So that's what I got hung up on just for a second. But let's see what we can do here. So first thing I'm going to do is 2,000 yards, put it over 1. And I want to multiply by unit multiplier. Again, what do I want to get rid of? I want to get rid of the yards. And if remember our little chart, let's skip back up there just a second. I want to change to meters. So 1 yard is 0.9 meters. Let's jump back down here again. So 1 yard is 0.9 meters. All right, so what did I just do right there? I just changed to meters, but they want kilometers. So what I'm going to have to do, which is not on that other chart, it's on a chart we did yesterday. What I want to do is change from meters to kilometers, and that's kind of easy because remember the kilo, that prefix means 1,000. So if meters is on top, I'm going to put meters on the bottom, and I'm going to put kilometers on top. So 1 kilometer equals 1,000 meters. So that's something that we did yesterday. All right, so the meters now cancel out. So look what I did. I canceled out the yards, turned it into meters, canceled out the meters, turned it into kilometers, and that's what I have. So now I just have to work with this number right here, and you put all that into your calculator, 2,000 times 0.9, divide that by 1,000, or I could just do this. 2,000 divided by 1,000 is 2 times 0.9, which is just 1.8. And so that's approximately 1.8 kilometers. Okay, let's go to, that was length. All three of those examples that we did were length. Now we have capacity. Capacity is like volume, okay, it's how much space it takes up. So we've got quarts and pints like we did. We've got liters, and those are basically the three that we're working with right here. Okay, one quart is 0.9 liters. 1 quart is 0.9 liters. So you can see the relationship there. 1 pint is about half a liter. These are all approximates. They're not exact values. 1 pint is half a liter, and these are just the reverse of those. All right, let's do an example. So once you know these, then it's not hard to do these, and that's a lot to remember. So on a quiz or a test, I'm going to give you these charts. I think yesterday I might have said you need to remember them, but I'm going to give them to you because it is a lot to remember. I'm just really more concerned that you know how to use them. That's what I'm concerned about. So let's see the first one. 7 quarts is equal to how many liters? All right, if you look at this, these are the easy ones because there's a direct relationship between quarts and liters. So I've been doing these a bunch now. You should be used to this. 7 quarts over 1, and now we got to figure out what we're going to get rid of. We got to get rid of the quarts, so that's on the bottom, and we can change it directly to liters because if you look at this, we can go directly from quarts to liters. So I can put liters on the top. Now, how many quarts, how many liters? Well, 1 quart right here equals 0.9, approximately 0.9 liters. And now we just do the math. This is all over 1, so you don't have to do any division. The quarts cancels out, so 7 times 9 is 63. Move the decimal, it'd be 6.3 liters. Just like that. All right, let's do another one. We'll scooch this up. I tell you what, let's keep this chart in our view so we can refer back to it. This says 2 liters. Now we're changing. We're going 2 liters, and we want to find out how many pints 2 liters is. Okay, how many pints? So again, do we have a relationship between pints and liters? Absolutely, right here, liters and pints. Or you could have used this over here if you wanted to. You could use either one of them. We'll use this one. 2 liters, put it over 1. Now we need to multiply by a unit multiplier. Liters is on top, so we put liters on the bottom. And we're changing it to pints, so we put pints on the top. There is a direct relationship here. The liters cancel. Oops, let's put some numbers in here. Okay, it's 1 liter and 2.1 pints. Should have done that first. Now the liters cancel, and now we just work that out. That's an easy multiplication. That 2 times 2 is 4.2 pints. And there you go. Notice what I'm doing. I'm showing all my work. I haven't mentioned this yet, but I am showing all my work, showing all the steps. I write the problem out first, then I show my steps, and I get my answer, and I circle my answer. That's exactly what you should be doing on your work, on your class work that you turn in to me. All right, here is another one. Okay, for this next one, I put the charts up here so you could see them. We're going to go back to a chart we did yesterday. This is all English system. It's going from one English system to another English system. And for this problem, we're going to need that one. So here is the problem. It's 10 liters, and we want to change that or convert it to gallons. So how many gallons is 10 liters? Now, if you go to Canada and you put gas in your tank, you're going to put liters in there. And you might want to know, well, how many gallons? I want to put 10 liters in. How many gallons is 10 liters. So it can be very, very useful to you to know how to do this, this kind of thing. So let's do what we always do. Start off with 10 liters and put it over 1. And let's think a little bit. We want to get rid of liters, so we're going to put liters on the bottom. We want to change it to gallons. So if you look on here, the only place I see gallons is right here, but it doesn't tell me how many liters that is. So what am I going to have to do? I'm going to have to come over here and look at the gallons. It tells me how many quarts are in a gallon, 4 quarts in a gallon. So let's come over here. Let's not use the pints and liters. Let's use the quarts and liters. So I'm going to use this one. So I'm going to change it from liters to quarts. Why did I change it to quarts? Because I know how many quarts go in a gallon, and that's eventually what I want to end up with is gallons. Okay, I hope that makes sense. That's the hardest part, is just knowing which one to go to first, that in-between one. So I look at liters and I say, oh, I can change that to quarts. And now I know how many quarts. I can change that to gallons, and then I'll have what I need to have here. So let's do this. Let's do this one right here, liters to quarts. So how many liters? 0.9 liters. Now, if I wanted to, I could have used this over here. That might have been actually a little easier, but let's just do it this way. Let's just pretend we didn't think about doing that, because you could do either way. Just want to show you that you could do either way. So 0.9 liters and 1 quart. And you're thinking, well, I didn't change that to gallons. That's not how many gallons. That's how many quarts. Well, oops, don't put equals there. Put a times. So what I'm going to do is come over to the quarts and change it to gallons. Quarts on the top, quarts on the bottom, and then I can change from quarts to gallons. And now once I do all my math, I'll have it all out. 1 gallon, put that on top, equals 4 quarts, put that on the bottom. And now we can work this thing out. Look what happens to the liters. They canceled because one was on top, one was on the bottom. Look what happened to the quarts. They canceled because one was on the top, one was on the bottom. What am I left with? I'm left with gallons, and that's what I wanted to end up with. So now I just have to do the math. I have 10 on the top times 1 times 1, and then I've got on the bottom 0.9 times 4. And that's going to be in gallons. So let's just chuck that in our calculator and see what we get. Let's clear that. So I've got 10 divided by, let's put this in parentheses, 0.9 times 4. All right, and then we get about 2.77, or about, let's say 2.78. All right, 2.78 if we round it to the second decimal place, since it repeated. That's how many gallons is 10 liters. So if you go to Canada and you say, okay, I want you to put 10 liters in the car, well, you're only getting a little less than 3 gallons of gas, okay? So 10 liters is really not a whole lot when it comes to putting gas in your car, but that's how we do it. Now, if you look in the book, you're going to get a slightly different answer, because they used this one right here, this 1.1. That's an inverse of 0.9, but it's not an exact inverse of 0.9. So if you use 0.9, you use 1.1, it could be off just slightly. I think they say 2.75, but I'll understand what you did. I'll see your work. If it was a quiz or a test, I'll see your work, and I'll know why you got that answer compared to 2.75. So if you got 0.75 or 0.78, you would get credit either way. We got one more to do. Well, one more type of problem, just 2 more examples, and we'll be finished. All right, this is the last one. We're doing weight or mass, depending on which one. Yeah, talk to your science teacher about the difference between weight and mass. They'll discuss that in there. Basically, in here, we'll just pretend it's the same thing. There's a slight difference, but we'll just say it's the same thing. All right, here we go. Let's do an example. Here are units, ounces and grams. We've seen all of these before. Now we're converting from one system to the other. 1 ounce is 28.3 grams. It means there's a lot of grams to make 1 ounce. We think of 1 ounce as being small, but a gram is way smaller. It takes 28.3 of those grams just to make 1 ounce. Look at this. What's the difference between kilograms and pounds? Well, 1 pound is only half a kilogram. All right, so it takes more kilograms. Now, this is approximately, it's not exactly, right? But it's about 0.5 kilograms makes a pound. If you look over here, 1 kilogram is 2.2 pounds. All right, so So it takes more kilograms to make a pound. All right. And same thing here, 1 gram. These are just inverses of each other. They're basic inverses of each other, because the inverse of this would be 2, but this is really 2.2, so this is not exactly 0.5. Hope you understand that. All right, well, let's just do this problem. 58.5 kilograms, 58.5 kilograms, and we are going to change that to pounds. Sometimes I remember when my kids were born and they weighed them. They weigh them on a scale and it's in kilograms. It's not in pounds. And so they have a little chart on the wall with all these numbers, and they actually had to do some conversions to figure out how many pounds, because I didn't know in my top of my head what it would be. And so we're used to pounds. And so they told me how many pounds my kid weighed by looking at a little chart that had all these conversions on it. All right. 58.5 kilograms. And we're going to put this over 1. We've been doing this for the last 2 days now. That's a little squiggly. Let's try that again. It's a little better. And what's going to go on the bottom? Well, I'm trying to get rid of kilograms. So put kilograms on the bottom so they cancel out. And I'm going to change that directly to pounds. Can I go directly from kilograms to pounds? Absolutely. Okay. I could use either this one or this one. Which one would you probably rather use? Well, I kind of like the bottoms to stay 1 if I could possibly do that. So look over here. 1 kilogram is 2.2 pounds. So I'm going to use this one. You can use either one, but I think this is a little bit easier. 1 kilogram is 2.2 pounds. So 2.2 pounds. Now, again, you have to be careful on your answers, because they could be slightly different depending on which one of these you use. Because, again, these are approximations. Even though it says equal, they're still approximations. All right, so now what do we do? Well, I would like to put that in my calculator. Instead of writing it out, I don't think I can do that in my head, so let's do this. 58.5 times 2.2. All right, and that's 128.7. 128.7. 7 what? 128.7 what? The kilograms canceled out. What am I left with? I'm left with pounds, so that is pounds. Okay, so 58.5 kilograms is 128.7 pounds. All right. Let's see what else. There's one last one. There it is. Let's change colors just a little bit. 14 ounces. Let's go ounces on this one. 14 ounces is how many grams? Put a question mark here. Put grams right there. Do we have ounces and grams? Absolutely. So let's go ahead and do this. This is the last one we're going to do. 14 ounces. Put it over 1. Now, what am I going to get rid of? I want to get rid of ounces, so I put that down on the bottom. I want to change it to grams. I put that on the top. They'll cancel out. But let's put the number here, grams and ounces. So I could either use this one or I could use this one. Which one would you rather use? I'd probably rather use the one with ounces as a 1. Do you see that? 1 ounce. So I'm going to put the 1 right here, the 28.3 on the top. I don't know, for me, multiplication was always better than division as far as knowing how to do it. Even though I'm using a calculator, it really doesn't make much of a difference. So I cancel out the ounces, I multiply those together. Let's move my calculator over. And so what is it? 14 times 28.3. Now again, using a calculator, there's really no difference in how hard it is, but I just decided to do that. 396.2. So it's about 396.2 grams. Remember, there's a whole bunch of grams that makes up an ounce, so that grams is going to be a lot bigger of a number. And that would be it. If I went a little fast, go back, rewind, and and watch little parts of it again. You don't have to watch the whole thing again, but just watch the little parts that you might have not understood. So our homework, or classwork, I guess, if you want to call it, is page P7. Remember, this is before you actually get to the real page 1. So we'll call it P7, and we're going to do 1 to 21. Do them all. Numbers 1 to 21. And that is your assignment for in class. That would be it. Hope you enjoy it. All right, if I can click out of this. All right, I'll see you tomorrow.